Alright, in this section, section 2.4, this is pretty much taken on all the different combination of sections that you've seen in your previous courses and kind of like putting it in one section. Now, the good thing in chapter 3, we're going to start narrowing things down. For now, things are broad and we're covering seem to be a lot of different ideas. So for example, 2.3 in intermediate algebra was actually 4 sections. In this class, they put it in one section. And the same with this section here. This is multiple sections. So after chapter 2, we will start, at least the ideas will start leveling off a bit, and you won't have as many ideas per section. They'll start being more focused. A polynomial is written in this form, in which these powers are positive integers or non-negative integers, because you could have x to the 0, but they can be negative, but they're integers. And those numbers right there, those are any number that you want. They could be any real number. Polynomials we study a lot. We have a whole chapter on this coming up in this class. For now, if you want to solve a polynomial, you get 0 on one side, everything else on the other side, just like quadratic, and you factor. So when I'm glancing at number 6, I start with, well, I see a polynomial. To solve any equation in math, you isolate the name by itself. That's an easy way out. And how do I identify the name of an equation? Well, polynomials are right there. To really solve a polynomial, you isolate the polynomial by itself, meaning get the polynomial on one side, everything else on the other side. Well, if you look at that, it's always a 0. So this is 6x to the 5th. If I subtract 4x to the 4th on both sides, that will make this a 36x to the 4th plus 48x cubed equal to 0. First step in factoring, greatest common factor. I see that 6x cubed is common in all of those. Take this divided by 6x cubed, that will be x squared. 36x squared divided by 6x cubed is a positive 6x. 48x cubed divided by 6 is a positive, what is that? Is that 8? Yeah, 8 times 6 is 48. That's right. So, now what? Now, I'll say this is 6x cubed, and 2 factors of 8 that add up to give me a 6, well, obviously a 4 and a 2. And now what? Either 6x cubed equals 0, or x plus 4 equals 0, or x plus 2 equals 0. X would either equal a 0, a negative 4, or a negative 2. There it is. If I look at problem number 4 on page 129 in our book, same deal. I see a polynomial. I say, okay, well, let me get everything on one side, 0 on the other side. 2x cubed minus 3x squared minus 2x plus 3. So I need to get a 0 every time I see a polynomial. I see 4 terms. I know how that game is played. I'm going to take the first 2. The greatest common factor between those is x squared, and that will be a 2x minus 3. Do remember that you take that sign most of the time. There's nothing there, so just a 1. That's the common between those. 2x minus 3. And we always notice that this is the same. If I factor out 2x minus 3 out, I'll have an x squared and a minus 1. And I notice I could factor one more step. This is 2 terms, perfect squares with a minus. I write the x and the 1, the non-squares. 1 time minus 1 time positive. Doesn't this mean that x will equal a 3/2, a 1, and a negative 1? So I skipped one step in there. And there it is. And the next set of problems. Solve each equation. What kind of an equation is that? Well, at first glance, I'm glancing at the first one. I see that's a radical. So that's called a radical equation. How do you solve any equation in math? You isolate the name by itself. So a radical equation, I would isolate the radical by itself first. And what does that mean? Move the 6 over. And how do you think we're going to get rid of a square root? We square both sides. And what do we get? The square cancels the square root. We get 3w plus 14 equal. And here I need to FOIL. If I FOIL this, that's 9w squared minus 2ab 36w plus 36. And now if you look at the green equation, can you guess what that looked like? So even if you didn't start the problem with a polynomial, guess what? Roughly 75% of the time you're solving an equation in math, you end up with a polynomial anyways. So 0 on one side, everything else on the other side. 9w squared, subtract, that's minus 39w. Subtract, what's that? 36 minus 14, that's a 22, if I'm not mistaken. Okay, I gave it more space. So how does that work? 9, we're thinking 3 and 3 closest. 22, isn't that 11 and 2? I need them to add to get me a 39. 6 and 33, if you add those, that's a 39. How do you get a negative 39? Both negative. So the 3 and the negative 11 in one parentheses, the 3 and the negative 2, the first has a variable. So that means either 3w minus 11 equals 0 or 3w minus 2 equals 0. Move the 11 over and divide by 3. Move the 2 over and divide by 3. There is a small catch. Every time you start the problem with an even index radical, every time you start the problem with a fraction, and every time you start the problem with a log, you need to kind of eyeball the answer. Make sure it's allowed because domain applies. I don't know why I moved to the left. Okay, I love it when it does that. Here we go. It seems I started on the right and I started kind of merging to the left if you look at that. There we go. Okay, 11 over 3. I'm just trying to make sure that that satisfies. 11 over 3 right there, that will make that 11. 11 over 3 there, that will be 11 plus 14, that's 25. That's 5 plus 6 equal 11. That's really heavy, you have to check it. 2/3, if you put 2/3 right there, 3 times 2/3 is 2. 3 times 2/3 is 2 plus 14, that's 16. That's a 4. 4 plus 6 equal 2. That doesn't work. So again, you take 2/3, you put it right there. 3 times 2/3 is a 2. 3 times 2/3 is a 3. 3 times 2/3 is a 2. 2 plus 14 is 16. Square root of 16 is 4 plus 6 does not equal 2. You take that out. Every time you start the problem with an even index radical, you need to check your answers. The next problem is identical. I see a radical, but they already isolated the radical by itself. That's good news. All what I have to do is get rid of a square root, square both sides. Can you guess what you need to do if you have a cube root? You would actually cube both sides. If you had a fourth root, raise to the fourth power both sides. It looks like I need to adjust this a bit. It's going to take a bit more space than I want it. Well, what does that mean? The square cancels the radical. And here I need to FOIL those. FOIL meaning I'm going to multiply this by itself twice. Well, if I multiply this together, the radical cancels out. That's good news. When I multiply this, I'll get 3 times the square root of 2x plus 1. 3 times the square root of 2x plus 1. And 3 times 3 is a 9. So this says 8x plus 4 equals 2x. 1 plus 9 is a 10. Plus 3 of those plus 3 of those, 6 of those. Now if I was to ask you what kind of an equation are we looking at, we're still looking at a radical equation. Isolate the radical by itself. Subtract 2x from both sides. Subtract 10 from both sides. Divide by 6. Now, do you see it's more beneficial to divide each of those by 6 instead of the whole side? We were talking about that last time. And now, if you square both sides, because that's how you get rid of a square. But we did that already. Yeah, you have to do it twice in this case. The right side is simply 2x plus 1. The left side, if you FOIL this, multiply it by itself, that's going to be x squared minus 2x plus 1. I'm dealing with a quadratic again. Get everything on one side, 0 on the other side, x squared. If you subtract 2x from both sides, that's minus 4x. Subtract 1 from both sides, factor an x out. So either x equal a 0 or a 4. Again, I started the problem with an even index radical. I need to check my answer. And checking, you just do it by glancing at the problem. If I put a 0 in for x, 0 right there, that means that's a 4. Square root of 4 is 2. A 0 right there, that's 1. Square root of 1 is 1. 1 plus 3 is a 4. 2 does not equal to 4. 0 didn't work. So no need to write. You could write it down. There's no need to. X equal 4. If I put a 4 right there, 4 times 3 is 32. 32 plus 4 is 36. Square root of 36 is 6 equal. If I put a 4 right there, 2 times 4 is 8 plus 1, that's 9. Square root of 9 is 3 plus 3 equal a 6. That one checks. So anytime I start the problem with an even index radical, a fraction, or a log, I have to check my answer because domain applies. Now at first glance at number 14, it might seem to be not matching, but if you really think about it, this says this is the square root of y plus 3 equal twice the fourth root of y. If I raise both sides to the fourth power, the right side, 2 to the fourth, and this cancels that radical. The right side, this would be, so if I raise this to the fourth power and this to the fourth power, half of 4 is 2. So this says y, I need to add more space. There we go. This says y squared plus 6y plus 9, I FOILed. 2 times 2 is 4, times 2 is 8, times 2 is 16y. A polynomial, get everything on one side, 0 on the other side, factor. So y equals a 9 or a 1. Do they work? Right there. If I take the 9, put a 9 there. 9 plus 3 is 12. This says the square root of 12. And a 9 in there says twice the fourth root of 12. Oh boy. I can't see it being the same. If I put a 1, square root 1 plus 3 is 4, square root of 4 is 2, fourth root of 1 is 1, equal 2 times 1, 2 checks. There it is. Another kind of equation would be a rational equation, like this problem 16. Here, you should be thinking of an LCD once you see a fraction. The LCD is x plus 1 times 5. And you want to make all of these over the same denominator. What do you multiply this with? A 5. Whatever you multiply the bottom with, you multiply the top with, a ratio of 1. This is missing x plus 1. And this is missing a 5. So if I ignore the bottom and just read the top, this is really what that problem reads. And if you clear the parentheses, 5x plus 20 plus x squared plus x, 10x plus 25 x squared. 5 plus 1 is 6. And this is a polynomial. Subtract 10x from both sides. Subtract 25 from both sides. Factor. So x equals a 5 or a negative 1. Very good. But again, the catch. If you deal with a fraction, 5, you cannot make the LCD equal 0. 5 in there, that will make that a 6. Do you see if I put a negative 1 right there, I'll make it a 0? I can't have that. So all different kinds of equations. How about number 20? Well, number 20, I glance at that, say, okay, that's a polynomial. Let's get everything on one side, 0 on the other side. Subtract this from both sides. Minus 8z to the 5th plus 15. Now, here's the deal. If this is the square of that, meaning if I take the middle piece and I square it, isn't that z to the 10? That tells me this is quadratic. So 1 and 1, and closest factors of 15 are 5 and 3. I need them to add to get me 8. 3 plus 5 is 8. Since I want a negative 8, I want the 5 to be negative and the 8 to be negative. The 1 and the negative 5 are put together. The 1 and the negative 3 are put together. And do you remember how I did this? I'm going to split this in half. What's half of that? Isn't that z to the 5th? So this says z to the 5th minus 5 equal to 0, or z to the 5th minus 3 equal to 0. Move that over. Z to the 5th equal a 5. How do you get rid of a 5th power? You take the 5th root of both sides. Z will equal the 5th root of 5. And here, you would move the 3 over, and you would take the 5th root of both sides. Z will equal the 5th root of 3. The last portion of this section deals with absolute value equations. If a and b are some numerical and some numbers or algebraic expressions such that absolute value of a equal b, then a would equal plus or minus b. Or you could say a equal to b and a equal to negative b. It doesn't matter where the negative goes, it works the same way. So if I look at number 24, the goal is for you to isolate the absolute value by itself. So absolute value, in case you've forgotten, is always positive or 0. So if I get an absolute value on one side, everything else on the other side, then I could say whatever this other side is, it's going to be a plus or a minus. Keep in mind, absolute value can never be negative. If you ever see that, automatically you say there's no solution, no matter what. The outcome of an absolute value is always positive. So here I notice there's an absolute value there, and there's a positive there. So I could say 6x plus 4 equals a plus or minus 5. Just like it's right there. I could separate this, I could split it up, I could leave it as is, it doesn't matter. So I could say this is, I'm going to do it both ways for you just to make sure you see it. So one way of doing this is for you to say, you know what, I'm going to subtract 4 from both sides. I'm going to divide by 6 both sides. X would be negative 4 plus 5 is 1 over 6, or negative 4 minus 5 is negative 9 over 6, and x would be 1 over 6 or 3/2. Or you could say at this stage 6x plus 4 equal a 5, or 6x plus 5 equal a negative. I got it backwards. Oh yeah, no, I did. You could say Or you could say negative 5 equals 6x plus 4, or negative 5 or positive 5 equals 6x plus 4, and solve it. Whatever works. There's really no set way of doing that. You could do it either or. So when I get to number 26, I'll say absolute value is by itself on one side. 5 over x plus 2 equal plus or minus 7. So here probably I'm better off splitting this, because there's an x. Well, clear the fractions. LCD in this case will be x plus 2. This is missing an x plus 2, top and bottom. That would be 5 equals 7 into x plus 2. 5 equal 7x plus 14. If you subtract 14 from both sides, if you subtract 14 from both sides, 5 minus 14 is negative 9. Divide by 7, x would be a negative 9 over 7. Or LCD is x plus 2. Multiply top and bottom by x plus 2. That would read 5 equal negative 7 into x plus 2. 5 equal negative 7x minus 14. Add, how am I going to organize this nicer? I don't like this. Okay, I figured out how to do this. Let me take this out completely. So here, you know what? Right there. Why not? Okay, and here we had, what did we have? We had 5 over x plus 2 equal negative 7. LCD is x plus 2 multiplied by x plus 2 top and bottom. Clear the denominator. 5 equal negative 7x minus 14. Add 14 to both sides. That would be 19 equal negative 7x. Divide by a negative 7. There it is. Alright. And if I look at, so maybe I should have kept those underneath. That would have made things very easy. Right? That's okay. How about here? The same deal. I could say 3x minus 4. I have an absolute value on one side, everything else on the other side, equal to 1. Or 3x minus 4 over 2x plus 2 equal a negative 1. I'm going to start writing nicer. Well, LCD in this case is, in both cases, 2x plus 2. So you multiply this by 2x plus 2, top and bottom. Multiply this by 2x plus 2, top and bottom. Ignore the denominator. That says 3x minus 4 equal 2x plus 2. X minus 4 equal a 2. X equal a 6. And here you clear the denominators. You will get 3x minus 4 equal a negative 2x and a minus 2. Add 2x to both sides. Add 4 to both sides. And divide by 5. We did start the problem with a fraction. I forgot to mention here too. Since that's a denominator, x cannot make the LCD equals 0. X cannot be a negative 2, which works here. And here, x cannot be a negative 1. It's not that, and there it is. And let me list the homework. And there's the homework. 2.4, page 129, number 1 to 29 odd, skip number 17.